So far, yeah. Every one of these gets added to the end of the year. Don't make any early vacation plans, that's all I gotta say. I do think they're looking in, well, that might be for next year though. I think they're looking into some way where, like, each week you have to go to classes so many hours per day, but I guess we go a little bit over that. So, like, in theory, if we went to school this whole week, then I think we can bank that time to the next week. So, like, then if we had a snow day the next week, we wouldn't have to make it up because we could count the extra time we did the week before. I don't know. They're looking into something like that, but that may not be till next year. And also, it only works if you went to school a full week the week before, so. Well, it would be like maybe some of the snow days we would take, not all of them would have to be made up. Some of them we could work around. But that's not set up right now, and probably won't be set up this year. Olivia's gonna be late. All right, first thing before we get going on here, I'd asked you guys last class or for homework to turn in 2 things in a Google Classroom that was 73 and 75. If you were not able to do that or you forgot to do that, you need to do that right now. In just a couple minutes when I start looking those over, they'll be late if they're not in there. So you might want to double check that. So today we're going to take a couple quick notes for handout 76. We need to talk about the difference between distance and displacement, which comes up a lot in our FRQs in this section. Then I'll ask you to get out number 74 out of your binder. That was the big packet I gave you last class, and we did the first FRQ. And we need to review the first one because that's going to be helpful to us at the end of class today. Well, it'll be helpful to us a couple times today. But we're going to do 2 more. There's 4 total, so that'll get us close to being finished with that. I will ask for 76 to go into Google Classroom, and then we'll move on to the circuit on accumulation models. So you're not quite ready for that one yet, but that's part of what we will pick up between now and then. All right, 76, difference between distance and displacement.
So do you have extra of this one?
They'll be at the bottom of the bookshelf over there.
Thank you.
All right, so if you were to walk 5 feet to the right and then 4 feet to the left, what do you think your displacement would be?
1 foot.
Okay, just 1 foot. All right, Grace, you need to wrap up the conversation. So 1 foot total. So what displacement means is how far something is from where it started. So, for example, if we all tried to calculate our displacement from like when we woke up this morning to when we wake up tomorrow morning, for most people that displacement is probably next to 0 because you're probably going to be in the same spot tomorrow morning when you wake up than when you woke up this morning. So it's all about how far away you are from when you originally started. But if you went 5 feet to the right and then you went 4 feet to the left, this is the one that's going to come up a lot for us. What would your total distance be? Good, 9 feet. So notice question 1 and 3 are almost the same thing, but if you want to know the total distance, you just want to know how far you're traveling. Your total distance that you travel in a day is probably not going to be near 0. That would just mean you stayed in bed all day. So whether you're going left or down, we would want to include those towards the total distance. Whereas if we are going left or down, we would want to take that away. This is like 5 minus 4. We'd want to take that away from displacement. All right, so in your own words, what's the difference between displacement and distance? So again, I'd prefer you to word this in whatever way makes the most sense to you. But distance is going to be, I'm going to say something like whether, something about whether you go right, left, up, or down. All contributes to total distance, whereas displacement only cares about how far something has traveled, or how far something is from where it started. Again, feel free to put that in your own words. So I don't know that you're going to see the word displacement a lot in here. But we will be asked about where, like a particle, or where the position of something is. So if we know where something starts, and we know how much displacement it has, we can pretty quickly calculate where its position would be. But even more than that, we're going to have questions that ask us the total distance traveled. So even with integration, just like the area under the curve, the stuff above the x-axis is positive, the stuff below the x-axis is negative. So in general, the positive area tells us something's changing to go right or up. The area under the x-axis is usually telling us the change that it's occurring left or down. But if it's total distance, you want to make sure you add all of that. Whereas displacement, you only care about how far away it is from where you start. Okay, so all that to be said, what's the mass symbol that we can use that always returns a positive value?
Absolute value.
Good. Absolute value. So when we see something that says the total distance, what is the distance traveled? What's the total distance traveled? You need to think of absolute value. Because if something's going to the left, I don't want that to subtract from my distance. If something's going down, I don't want that to subtract from my distance. Whether I'm going left or down is still adding to my total distance traveled. Same way, this one went left 4 feet, but I still added it to the total distance. So whether it's 5 and -4, I want to think of each of these in a positive light. That's how you get that tonight. So I'm going to refer to that just a few more times today, and you will need to start applying that and making a habit out of that. Okay, if you did not get out the packet of 4 FRQs, that should be numbered as 74 in your binder. I'm actually going to switch this order up just a touch. I want to remind you what we looked at last time, just one part of it at least, because this is going to be important to some of the other FRQs, but this is going to be basically what the entire circuit's about. Okay, so the thing I want you to look at before we go on to 2 more of these today is, remember, integration. Integration visually is like area under the curve, or the area under the function. And so if we know the starting speed, starting location, the starting something, like we did on this question, was 55 feet per second, and we can calculate how the area under the function changes, either by physically counting up that area or through integration. The integration is what tells us how it changes over time. So if we know what it's starting at, and integration calculates how it changes over time, then we can figure out how things are being accumulated. So I would actually like to look at, again, I know these aren't perfectly numbered here, but if you could, let's look at this one. A little bit of this is going to be review, but again, it's good for you to kind of hear some of those things pop up here and there from last semester, so that when we get to AP review, if we have time for AP review, if we don't keep having a ton of snow days, you're not starting from scratch there. And this is a calculator one, so you might want to get your calculator turned on. Okay, the one I want us to look at says a particle, and again, this is a real FRQ. I know 1999 sounds like a long time ago, but of course, calculus or Cal 1, that has not changed very much since then. So, good chance you would see an FRQ like this or parts of this like this on your AP exam or on our next assessment. But we have a particle that moves along the y-axis, so that just means here's the y-axis. You have a particle on there that's moving back and forth, so it can move up or it can move down only. And they tell us the velocity is this when time is positive. So as time moves on, this tells us what the velocity is at any given moment. So if all I care about, A, is this guy going up or down? Is this particle going up or down at 1.5? How would I know if it's going up or down at 1.5? Positive what? Or negative what? Acceleration. Right. If the velocity is positive, remember this means it's going up, and if velocity is negative, it's going down. Remember that? Okay. So, in your calculator needs to be in radian mode. Calculus, there's no such, we don't do degrees in calculus, we do radians only. So you should simply plug in 1.5 into the velocity function. So in your calculator, 1.5 times the sine of 1.5 squared. I'm getting a number around 1.167. Remember that your AP exam always expects you to round to 3 decimal places without being told. Actually, it may be in the directions on the AP exam, but you know, you're probably not paying attention to those. So, what does that mean? Up or down? Okay. So, up is the answer. And what should our justification be? How do you know it's up?
Because it's a positive.
Because at that time, velocity is positive. So, answer and justification. Again, I went ahead and printed off the scoring guide, so you're welcome to look at it later. But 1 point, you had to have both of those. You have to also get your justification correct. Okay, part B. Find the acceleration of the particle at 1.5. And then some other stuff. So how am I supposed to know the acceleration at 1.5 if all I have is the velocity function? Okay, derivative of what? Okay, so the derivative of velocity is the same thing as acceleration. If you forgot this from last semester, this is still going to come into play a lot. Position, you could take the derivative to get velocity, and then you could take the derivative to get acceleration. Also in this semester, sometimes we go backwards. Sometimes we give you acceleration and some more information, and you can integrate to velocity, and then you can integrate velocity back to position. But you need to remember this kind of relationship here. So, what do y'all think that's going to be? Or what's the smartest way to find the answer to this? Can you take the derivative of this? Okay, what rule would that be? Okay, there is a chain rule, but there's also product rule because it's t times something. So, the trap you don't want to fall into is this one you can do by hand. But this is a calculator FRQ. There's no point in wasting your time and maybe missing it. Just go type it in your calculator. Alpha window, option 3 lets you do derivative work. It was 1.5 sine of t squared. I'm just putting x instead. And again, your calculator can do derivatives at a specific time. Except my calculator's in degrees, it needs to be in radians. There we go. So there's the first answer to part B. All you had to know was the acceleration is the derivative of velocity, and either be able to do it by hand, or even better, just know that you can throw it in the calculator. About negative 2 point. All right, something's off here. There's something I'm not thinking of. Oh, I didn't type it in correctly. That's why. My number's off here a little bit. I didn't type the function in right. I don't know why. Well, I do know why. I was trying to do it in my head without looking at the paper, but this is supposed to be the first one's not supposed to be 1.5. It's supposed to be an x or a t. Of course, if you want to use t's, just like your paper says, you can, but you need to put a t here, a t here, a t here, and it would automatically change that to a t. Okay, so that was close, but this is the actual answer. The derivative of velocity at 1.5 is the same as acceleration at 1.5. Easy to do because your calculator will do that for you. It comes out to be about negative 2.048. And we don't have units, so we won't worry about that. Okay, you can get 1 point. You can do that. But there's more to part B. Part B also wants to know, is the velocity increasing at this time? Why or why not? So do you think velocity is increasing or decreasing? Okay, I agree. And how do you know? Did y'all say increasing or decreasing? Decreasing. Okay, I just misheard you. And then I trusted your answer. Acceleration is negative, so it's decreasing. That's the answer and my justification. You need both of those for the next part. Again, comparatively speaking, these don't take a lot of knowledge or a lot of work. Calculator is doing the messy arithmetic. I just have to know these relationships. Okay, now part C, this starts to pull in some of the new stuff. And this is what pretty much every one of those circuit questions you're going to do in a few minutes is like. It says when x is 0, you start off with a position of 3, and they want to know what's the position at x equals 2. So I know it's starting off at 3. 3 is its initial position. And I need to know how does it move to get to x equals 2. So this is why I was speaking on this FRQ from last time. Again, I know there's a lot of stuff here, but the important parts were we knew the initial speed, and then the area under the curve, which is the same as integrating, told us how it changed. A little bit or area of 30 means the speed increased by 30. Another area of 30 means the speed increased another 30. An area under the curve of 30 subtracted the speed by 30. The area under the curve tells you how it changes. The area under the curve is also integration. So for this question, what we need to do is we need to say, I know his starting point is 3 plus how he changes comes from integrating. So I want to integrate the velocity function And what x values do you think I want to integrate from?
From 0 to 2.
Okay, why 2?
Because it says we're trying to find the position at y equals x equals 2.
Okay, so we want it to end at 2. How did you know we were starting at 0?
Because we have the position of the particle at 0.
Very good. So we knew the starting location was x equals 0. And so again, I'm going to phrase it like this a lot today. The initial, and in fact you really should write this down even though it doesn't matter for this FRQ. We have our starting location plus the integral tells us how it changes. Now, if this had said f or y of 1 equals 3, I would only want to integrate from 1 to 2 because I know the value at 1 and I want to know how it changes from 1 to 2. In this question, I know the value at 0 and I want to know the value at 2. So I know at 0, so start at 0 and then go to 2. Our calculator can do this as well. Once again, this is a conceptual question. They didn't try to test your arithmetic skills. This is what we need to type into our calculator. So we need starting point plus how it changes. So alpha window, remember option 4 will let you do a definite integral. So 0 to 2 is going to calculate how it changes from 0 to 2. And when we integrate velocity, it tells us how the lower thing changes. Integrating velocity will tell us how position is changing. No need to try to do that by hand. Now, once you guys learn U substitution in a few weeks, in theory, you could do this integral by hand, but it's kind of like the second part. Just because you could have done the derivative by hand, it's a waste of time, and time you will feel pretty pressed on the AP exam. You want to buy as much time as you can. So lean on your calculator as much as possible. This one was about 3.827. Comes out to be about 3.827. Remember, always 3 decimal places. So in this one, they gave a point if you had this set up correctly. They gave you a point if this is correct. And then the other point would just kind of depend on how you worked it. But how I had it would also get that point. Again, this is what we're going to practice here a lot today. Starting value, starting speed, starting location, plus the change comes from integration. The integration calculates how it's changing over time. But once again, notice I had to understand the setup, but I didn't have to do the messy arithmetic. Let the calculator do that. All right, finally, find the total distance traveled from 0 to 2. So I know velocity, so if I was to integrate velocity, this gives me the change in position. If the variable's t, you need a dt here. So what do you think my upper and lower bound should be here? 0 to 2. This is not what you want to put in your calculator. The problem with this is velocity can be positive or negative. Sometimes it's positive and it goes to the right. Sometimes it's negative and it goes to the left. Sometimes it's positive and it goes more to the right. Sometimes it's negative and it goes more to the left. Which is good if you want to know the position, how it changes over time, what we did in part C. But here, I wanted to calculate whether it's going left or right. I want it to always be positive. And what mass symbol makes sure that it is always positive? So total distance, you have to put the absolute value there. And then once again, this is ready to go in your calculator. You do have to know how to do absolute value in your calculator. So ask your calculator to integrate 0 to 2. And absolute value is in the catalog. It's also right here, the same menu that we're using for derivatives and integrals. Option 1, ABS, is for absolute value. Oh. There we go. So again, if it's positive, it stays positive, but when your velocity is negative, integrating that is change in position, but whether my position is going right or left, it should add to my total distance, which is why the absolute value signs are necessary. I don't know if you noticed that, but my calculator took a few seconds to do that. That's kind of tough for it. And there's the answer to this one, 1.173. 1.173. And again, you can look at the scoring guide if you'd like to. But it looks like they give 1 point if you get the upper and lower bounds correct. If you deal with the total value, so absolute value sign, looks like they gave a point for that. And then finally they gave a third point if you came up with the right number. This is going to be one of those things that you'll learn it eventually. Total distance, absolute value, because you're going to do it so often. But of course, the sooner you click with that, the smoother things will go. Okay, so things we had to know for this one. Velocity's positives going up. The derivative of velocity gives you acceleration. Can do that in the calculator. Figuring out the position of something, you can take the starting point and then add how it changes. And the way you can calculate the change is with the integration. And then total distance traveled. The total distance told me absolute value. And since I wanted distance traveled, integrating velocity tells you the change in position. So that's why that works the way it does. Okay, anything you want to clarify about that one while it's still up there? Okay, then let's look at one more today. I will also add, I think this is good news, but it's something to keep in mind. Over the last 5 or 6 years, your AP exam has been moving away from being less computational, which means like those long problems where you have to do a bunch of steps, adding fractions and multiplying by conjugates. And they still have you do that stuff, but there's less of that, and it's becoming more conceptual, where just like this one we just did, there's really not a ton of work to be done, but you have to know all these relationships. You have to know how to use your calculator. So I think that's good overall, but just something to keep in mind. All right, this one, again, there's going to be one left over for us to do later, but I want to do this one today. An object moves along the x-axis. So this is kind of like the last question, but instead of going up and down along the y-axis, it's going left and right along the x-axis. So here's my little object. At time equals 0, it's at an initial position of 2. And once again, they gave us a velocity function. Okay, if I'd like to know the acceleration at t equals 4, what's the relationship between acceleration and velocity? How do I take a velocity function and help me know something about acceleration? With derivative. So in your calculator, you can ask it to do this derivative. And you should get, just for time purposes, I'm going to just cheat. We just did that in the calculator. So it's either 0.523 or 0.524. On the AP exam, they'll count either one. If you round correctly or if you truncate, they'll give you a point. So simply knowing the derivative of velocity gives you acceleration. We said that on the last one. Okay, part B. This is the thing we took notes on last class, the short notes. Consider the following two statements. Statement 1. When time is between 3 and 4.5, the velocity of the object is decreasing. And then statement 2. When time is between 3 and 4.5, the speed of the object is increasing. So velocity decreasing, speed increasing. Are either or both of these statements correct? Provide a reason why it is correct or not correct. All right, so let's look at this one. During this time, is the velocity of the object decreasing? What do you think? Okay, I would agree. How did you know? How do you know it's decreasing?
Acceleration is negative.
The acceleration at that time is negative. Okay. Number 2, during that time, the speed of the object is increasing. Notice their differentiation here between velocity and speed. They expect you to know the difference between these two. So for the speed to be increasing, well, the acceleration's negative. Does that mean that speed is automatically decreasing? No, you have to remember the notes we took last time. You want the signs to be the same. If velocity and acceleration are both positive, speed is increasing to the right. If velocity and acceleration are both negative, it's increasing to the left. So at this time, we know acceleration is negative. During this time, velocity, well, I don't know, but I can plug that in. The sign at 4 pi over 3 is something negative. I know that because of unit circle, but this is a calculator question, so you could type it in if you wanted to. So the fact that velocity is negative means it's going to the left. And since acceleration is also negative, it means it's increasing its speed to the left. So this one is also true. I don't know if they want us to say yes or no or true or false, but that's what it's looking for. So 1 point, if you could see that this was true. 1 point, if you could see part 2 was true. Oh, actually they gave 1 point if you just figured out that it was true, and they give 1 point here if your reasoning was correct for part 2. Just think about the signs. If they're both positive or both negative, it is speeding up. If they have different signs, it is slowing down. That's all you have to do. That's all you have to check. That's all the justification you need. So you haven't used that yet, but I showed it to you last time in your notes so that we could start using it. Okay, part C. What is the total distance traveled over the object from 0 to 4? So if I have velocity, how am I supposed to figure out something about how position is changing?
Integrate.
Okay, so I'm going to integrate from 0 to 4. Integrating velocity tells me the change in the lower function, the change in position. You can do this and you can get an answer, but it's not going to be the right answer. So what did I forget? Right, I said total distance. I want to make sure that when it's going left or right, it's adding to the total distance. So that's what you'd want to type into your calculator. And this comes out to be about 2.387. Now, I want you to appreciate how easy this is compared to the comparison. So if I can find, yeah, here's the scoring guide on this. You can either do it the way I'm trying to get you to do it, right here, or you can do it by hand. And the way you do it by hand is you have to figure out when velocity is positive, keep that stuff positive, figure out when velocity is negative, make that stuff be positive, and then add those parts together. Either way, you're going to end up with the same answer. So I have no idea why you would ever want to try to take that path. Just total value or total distance, just do absolute value. Don't have to try to figure it out by hand. They will always let you have a calculator there. But if you can figure it out by hand, I guess you can still earn points, but pretty unlikely. Okay, now part D. This one I want you to think about a little bit because we're about to transition and a lot of this is going to be the same. What is the position of the object at time t equals 4? Okay, I actually want you to think about this one for a second. What would you use? Probably some integration thing in here somewhere, but think about what you know and how you can maybe piece some stuff together. Okay, what is part of this that you think we might need to have to figure out where it's at time 4?
2 plus.
Okay, very good. It's good to know where you're starting off at. You're starting off at 2, plus the way you can calculate how it changes is integrating. 0 to 4, I know the position at 0. I need to know how it changes from 0 to 4. Integrating velocity gives you the change in position. I don't want absolute value sign here because if it's going left, that impacts its position. If it's going down, it impacts its position. I need it to subtract from where it's calculating. Absolute value sign wouldn't be wrong here. So they give 1 point for having that set up. And then of course this is all ready to just be thrown into the calculator. So again, this is one you could, after we learn use substitution, this is one that you could do by hand, but why bother? You have a calculator, your calculator can integrate that for you. So 1 point if you come up with that number. So once again, notice I had to know a handful of things here before we move on, but calculator did the hardest part for me. I found acceleration by taking the derivative of velocity. Part 1 here, I knew the velocity was decreasing because it was negative. Part 2, I knew it was the speed was increasing because acceleration and velocity had the same sign. Part 3, you wanted total distance, so I integrated the absolute value. And part 4, trying to figure out the position. Starting position plus how it changes over time. Integration calculates that change over time. I know that feels kind of weird at first, which is why I keep emphasizing that, but that's exactly the same thing we did last time. It's just that instead of using the integration symbol, we calculated it with area under the curve. But these two things basically mean the same stuff. We had a starting speed and the area under the curve. How it integrated told us how that starting speed was changing over time. Okay, on to the last thing today. This is not it. All right. So this is a shorter circuit, but a couple of these are a little trickier, I think. You're going to take a little more thought. So let's look at 2 of these together, and then I will give you the rest of class to finish this up. I'll remind you the things I expect you to turn in before you leave, and then this one you can finish up for homework if you need to. All right, first off, on this one, they don't care if we do this by hand. We can use the calculator here. Of course, on the calculator questions, I'd like you to write down what you put in the calculator and your answer. But the non-calculator questions, you need to be showing more work than that. Okay, I would like to know f of 4. Right now I know f of 2, and I know the derivative of f. So this is basically the same thing we did on the last part of that last one. What is the starting position of this function? Okay, I would agree. I know it's at 5 at some time. To me, 5 is like a starting point. Starting point, starting location, whatever. It doesn't have to be at x equals 0. They can tell you whenever they feel like it. They happen to let me know when it starts at x equals 2. Okay, if I integrate, so I want to calculate the change. I want to see how it's changing. So if I integrate the derivative, that calculates the change in the function, the change in the lower one. So if I want to know f of 4, should I be saying from 0 to 4?
No.
Why not? That's what we did on the others on the FRQs.
The starting position is at 2.
Very good. The starting position should be 2 this problem. I know the position at time equals 2, so the change I need to calculate is really just how is it changing from 2 to 4 then. I already know where it is at x equals 2. Just tell me how it changes from 2 to 4. If you have it calculate the change from 0 to 4, then you're going to come up with a different answer. Once again, this is a calculator question, so you can type that in, make sure your calculator is in radian mode, and you can get your answer to move on. So some of them will look like that, and let's look at maybe let's maybe look at this one. Here's a good problem that is not calculator. Not calculator active, not calculator helpful, none of that. This is on the back page. This is similar to the first FRQ we did last class that I've referred to a couple times today. They tell you a value at C is 14. And you need to ingrain in your head that integration, which is the same thing as area under the curve, tells you how the lower function is changing. Since this is h prime, area represents how h is changing. So to go from 14 and I increase it by 8, at D I know it now has a value of 22. At K it would have a value of what?
12.
Okay, why not 32? Right, area under a curve is negative. Notice they're not telling you it's negative, you're expected to know that. And then backtrack. So this is one that students last year had trouble with. What do you think the value is at B?
26.
Very good, because whatever this is, take away 12 needs to get you to 14. It's tempting to say 2 here, but when you're going from right to left, you subtract, you don't add. 26 minus 12 gives you 14. And then finally, at x equals a, what would this need to be? 25?
4.
24. 24, because if you add 2 to that, it gives you 26. Area under the curve, which you can either be told, you can find through integration, or you can find the area yourself, like we did on the FRQ last time, allows us to see all of these values. I want the minimum value. So that looks to be 12. 12 is the smallest of those values. Or if the question had said max, I could quickly tell you that it happens at x equals b, and the max value would be 26. So again, sometimes you have to calculate area by hand. Sometimes you just need to apply the area that's given to you, and sometimes you find that area by actually integrating. But I think on this one, I think they let you use the calculator in all the integration questions. So, all right, so go ahead and finish typing this one in your calculator to know where to go on number 2, and then keep on going. Once again, I believe this should be possible to finish in class because you've got 45 minutes. But if you need more time, I guess you can finish it up for homework. This is a very, very, very important skill though. We're going to be using this a lot the rest of the semester. I'm going to switch the screen over here so you can remember what to turn in. 76 needs to be turned in before you leave. And 77 can be turned in also, but that one I need to have before next class.
Why is this 14 and not negative 14?
Well, it's just the value at that time. It has nothing to do with area. When x is c, the value is 14. So they're just giving you a starting point.
Oh, okay. So, wait. I'm so confused. So
It's
what
the
is
same
it?
as this one we did up here. At this time, the value was 14.
Mm-hmm.
The area tells you how it changed. So
Mhm.
14 plus 8 gave us 22.
Okay.
And then below the x-axis subtracted, so that gave us 12.
Oh, okay, thank you.
The area just tells you how it's changing. Okay, let me give you a few minutes head start, and then I will come around and help. Anything you need a reminder of.
So, when it says like 1 to x,
Mm-hmm.
so is it telling us to only take like the area starting from 1?
Mm-hmm. So you're going to start at 1,
Yeah.
and you're going to go to wherever your x value needs to be.
I got
So
it.
1 to 3.
Since I'm giving up 0, why write the interval and then subtract 5?
I would just integrate from 2 to 0.
Just 2 okay.
Yeah, your lower bound can be a higher number,
Okay.
and then it'll calculate it for you.
Okay.
But because you're basically going from right to left, it's going to make the value opposite of what it would be if it was 0 to 2, right?
Okay.
subtract. Because at 1, it's 2, and at D, it's 2. Unless you subtract it. I don't know what you're doing.
I treated like the geographic velocity graph as the position graph. So just really slow.
We'll just keep going and see like which one of us gets stuck.
The slope from 2 to 3. But I think the slope at that point goes by.
Doing the slope, yeah. That's why I didn't do it. I thought it would be simple.
I just replaced it with G.
You don't know what it is.
So I actually.
I was in a really rude mood last night. Like 2 nights ago. After practice. Did you mention it? Did she show you? Okay, I literally only showed her that so like she could show you. Have you seen the statistics? I wanted her to show you that one. After that statistics video, like it's losing her brains. He looks like this guy. So that's it.
That's just the value. The value could be anything. This is not a graph of f. This is the graph of f prime. So you know where f is at x equals 1, 3. F prime tells you how it's changing. So it doesn't matter because that's not two different things. Graphing f prime, 3 is the frame. But you want to know f of 5. So you need to figure out how much area you're going to have. And then your starting value plus
That's why I get you seconds.
it's like it's when you get to all the areas you actually have to do.
Yeah, where'd that do?
Yeah, but it was like
Just like,
no, it was
Well, if you don't have the function to integrate yourself, remember integration means area under the curve. So basically, it's going to know how much area is there for the 3. So you need to do the area of this triangle plus the area of this triangle.
oh, so then you just kind of have to calculate how
And they were all rich.
minutes, that many seconds makes
They were all
one.
because it was
Any questions yet?
so it was like Simmons chicken owners, like bank owners.
Any questions yet?
I don't know whether you're supposed to start with questions.
Okay, so with integration, you have to, part of what we're trying to get at is integration is visually is the same as area under a curve. So they're just asking you how much area is there from 1 to 3.
Oh.
So find the area of this triangle, find the area of this triangle, and add them together. It's really the same as this, except you have to figure out the areas instead of the areas being told to you. Found one I can help with yet?
Except for this one. I just kept it. Did you do That would be so funny.
Oh,
3 sounds too big to me.
sorry.
No, but it's from 1 to x. In this case, x is 3, so you really want to know from 1 to 3. And it needs to be the stuff under the function to the x-axis.
And then once we get that,
Oh,
want to try
there's
it?
one question like it, and it gives you like.
So you're trying to find f is an integral. Integration is the same as area under a curve.
And then it takes
It's just a visual representation.
So it's gonna be, and everything else you just plug in. I was gonna ask him about 6.
Well, if you do this one.
He helped me on that. He did 2 minus 3.
Okay. Well, if it helps you, you either know it or you don't. Why is it minus?
Oh, just looking at it all reversed.
I think you need to look back at that one.
Like there was so much. Yeah.
This wants to know the area from 1 to x.
Oh.
And what is x equal question?
What the X is,
So it wants you to find the area from down to 3. So you need to find the area of this triangle plus the area of this triangle. I don't know what that is, but it's not 0.
crazy. Okay.
Alright, it's just like this. You're adding or subtracting area, but in this case they didn't tell you the area, you have to find the area.
I think he was just saying this to the. It's like, I think he was with it.
To 3.
This is 1 to x.
X is 2. One times 2 over. Why is this? 2 over 1 is 2. Or over 2. Well, I guess.
That has an area of 1,
So it's 2.
and this has an area of 1.
That's what I got in the first place.
Okay, roll.
But I didn't do it that way. I just looked at this and at the same point.
You gave it a thumbs up?
Yeah.
So this is fine.
I mean, these had equal areas, so I don't know, maybe you thought this one and this one were balancing out. If this had been under the x-axis, then it would be 0.
So,
But
do you know why exactly to integrate, like, we use the derivative?
So you have something else?
Not just like this. I'm a little irritated. I know the derivative.
Alright, would you change the 13 2/3 into? Okay, that sounds good. That nephew value sign, that's good, because whether you're working right or left, you can't afford to total.
Wait, where's the?
Well, one thing is, this shouldn't throw your answer off too much, but you never wanna use 3.14, just use the pi symbol instead.
Oh, that's what it is.
3.14 is just an estimation, so that's gonna be a little bit off. You're gonna have to see the other questions. You're on the right track. Oh, no, so you don't wanna plug it in, you wanna actually have variables. You wanna integrate the whole thing, because as t changes, it can be changed, so when you plug in a number, you're telling it a number.
Yeah. Or I put 41 over 3.
Just put 13 plus.
That's what I was worried. Oh yeah, just
It's actually working. I'm actually done with
Oh, you're right. Does the bigger number always have to be on the top?
No.
For some reason, so maybe I need to subtract. Oh, sounds familiar. And that's another thing like this. It does.
I'm just saying.
Why do you think it's negative 1? Well, I think it's negative 1 minus pi.
So for number 7.
But I don't know, it should be negative 1 minus half. None of the extra negative 1 minus half. This one is negative 1. You don't really trust it.
Because you're getting the like last position.
Didn't look that much different from the one that you
I'm like surprised.
What I'm confused on is, since this is a quarter circle, I figure it would
So
be
this 26 is
minus half pi, or pi over 2. But,
Well, area of a circle is pi r squared. So if it's a quarter of that, it's gonna be pi r squared over 4.
we could just do it just like this. And this one
Is that what you're struggling with?
that's not what I was thinking. That's what was happening.
Is it because you're starting at 1 and going to -2? So going right to
I
left?
didn't think, I forgot it was the area. I was doing it from the, I was thinking in terms of like units. Because quarters are one equal half pi.
Quarter of a circle, if you have, that's true, okay. I see.
So I didn't think area.
But the difference between these two is this one's going from left to right and this one's going right to left. So I'm sure that you figure out. I'll come back and I'll figure it out.
So would you divide by 60?
I'm lost because I have everything to figure out for 60 except for the equation. I know that's probably not the solution for it. Okay.
Well, you don't need the equation.
Yeah.
Because to integrate from 1 to 2 is the same thing as the area from 1 to 2.
Well, I can
If you
take
found the area here, find the integration, find the area down here.
I think because these aren't closed shapes, it just confused my brain.
You just need to calculate the area from 1 to 2.
Okay.
Make it negative because it's below the x-axis. And that's what that is. It's just going to be 3 plus whatever that is.
Okay.
But it's a graph of the derivative.
got something different on that one.
Yeah, I don't really know.
Well, it's still the same amount of
I was
space.
listening to you guys and just playing.
Whether we draw the lines in for you or not,
I don't even know.
it's still a rectangle that's 3 by 1. So the area is still 3, or negative 3, because I go to the x axis.
So read parentheses and it's not row at the end.
Because I'm pretty sensitive.
I don't remember the number negative 6 coming from, but yes, you're right. You're going, well, look, we said this value is 12, did we add 10? See what I'm saying? Like, if you're going right to left, you're not, on the number line, you add, you go to the right, and you subtract, you go to the left, so you need to make all of that negative. Correct.
This is
Okay, but you're finding the area from 0 to 2. You can only find the area from 1 to 2 because you know the value when x equals 1. You don't know the value when x equals 0.
On this one?
oh wait, no, it's minus.
No, okay, so
Let's do my
the value is
The starting range? No, 1.
So because you start with the change is 0.6.
Oh, okay.
But you're starting with
3 plus.
okay, and then how it changes. So you know it's 3 when x equals 1, and you want to know when x equals 1.
How does that work?
You can either integrate from 1 to 2.
Because it's going to the left.
But since you don't have a function and you can't integrate it anyway, the next best thing is to find an area from 1 to 2.
Well, normally one
Well, it's the same.
Yes. Where are you getting the 0.6?
That's what this is. Let's do it 5 plus this was 5.6. So the change is 0.6. If I just subtract 4, that's 0.6 instead of adding it.
Oh, I see what you're saying. Okay.
From 1 to 2. In the function to the x-axis.
So this rectangle right in this one, so 1 times the thing, but it's positive. Well, it's 0.
It's not positive.
Yeah, oh, it's not 0.
That's 0 area.
No, I'm sorry, I'm working at 3 minus 3, that's negative. Sorry.
It's an area of 3, but it's below the x-axis.
So, thank you.
Okay, so you've got the starting value. Figured out what you need to calculate the changes. You don't have the function that integrated yourself. You gotta work on integration. You gotta add. So the next best thing is this is saying the area from 1 to 2. So how much area is there from 1 to 2?
We're wrong on 3.
From the area to the curve. If you integrate the derivative, this is what this function is. The final answer is
It's interesting. The 12th question, the answer is 12.
when you start off with a value of 3, plus to integrate from 1 to 2 is the same as the area under the curve from 1 to 2. Now it's the area from the function to the x-axis. So it's this rectangle. So you need to find the area of that rectangle from 1 to 2. Okay, so 3 from negative 3 is final answer is 0. The rectangle has an area of 3, but since it's below the x-axis, it's the same. So starting value, area under the curve / integration tells you how it changes.
So for these two problems, you said that this is not the right.
Yeah, yes.
I don't know what that is.
Well, I just
I got
like
1 plus
found where this was and then took out
Wait,
where this was.
You wanna know X three.
Oh, wait.
So,
Different way.
that's when X is 3, okay? So
This is
now
what I
we're gonna
had.
go F of 3.
Wait, did you?
Wait, did I do something
So
wrong?
you wanna figure out line G of T.
I put 10. I thought it was 10.
How much area is there from 1 to
I am
3?
also not this time.
Oh, I must have
Integration
done my
is the
number.
area under the curve.
So this answer is probably.
So how'd you do that?
Because from 1 to 3,
It's like the same as
some
the
area
first.
here, triangle, plus the more
Where
area
you
here,
like
another triangle.
that one? It's literally just like this, but in the other direction. So this is
No way.
because trying not.
Which question are you looking at? Y'all are like working on different questions with different parts.
Oh, yeah.
Trying to summarize
Oh,
two
the same.
things.
So,
It's the same book.
This
I
one
figured
here,
that the number 3, I
It
went
starts
to
at
number 6. So that one is negative 2, 1,
okay?
so that would be y, and then this is.
No, it's not negative 2 to right, it's 1 to negative 2.
It's like, well, this is F1. Oh wait, yeah, because the thing is, here you find out from 1 to 2 is
You didn't even go do this one first.
0.
Why do not
From
fit
0
0
you do this one, which is 1. And then it's 1 by 2. And then you do the quarter circle, which is pi. Oh, my bad. Oh, I got it. I was thinking of the whole part of the curve. So it's 2 is that quarter circle.
It's 2, 1, this one is 2. Okay. So the difference between that one and what you're calling number 6, I don't have the numbers. The difference is this one's going left to right, so look on the number line. If you want to go from left to right, you add. This one's going from 1 to negative 2, so you can still calculate those area parts, but because you're going from right to left, you need to make it negative.
So it would be negative 1.
There you go. It's correct.
So now this one is 6. And now we're stuck.
It's not that number. Change okay, that looks okay, except I would move to a mixed number. 13 and 2/3 would be, no. 26 over 3 is
So
like,
you got this one as 6 as well.
do 3 times 13 to get 39 plus 2, that'd be 41/3. We didn't change that to improve the fraction. The only other thing we got here.
Okay, say you were
But what did you do on 13?
say you were this.
This is the same as the other one, but
On a,
it says
on a
total
FRQ that's
distance
important.
traveled.
Say you were doing
That do what?
And what do you do with that, this? With that, sorry.
I wrote that one harder.
Yeah.
You know how we add it? So, we know that. Say you put the input. You're trying to find a starting point. What do you do with that?
That's right, you gotta do this thing.
Where?
If you've got 5 plus 3 equals 8, then if you don't, you do it. You're subtracting from top. Since 5 is the input, 5 is the
Right
output.
here, under the curve, it's telling you how to change.
This is just a messing between. This is always gonna be a messing between.
It's a rectangle.
2 minus 12 gives you 14.
Do you know what I'm saying?
I do. Negative 10 minus 12 gives you 14.
So it's
I don't know why you took the derivative.
That's just the information you get. When X is Z,
You took the derivative of
and then
The area under the.
You don't have to do that.
Wait, I think that's
so minus 12 equals 14. If you're going right to left, you want to be added. Oh, maybe it's right, you're going, there's, left to right, you add. Right to left, so you're. Yeah, you see all the values, max is 26, min is. Wait, what did I expect? Area for, shows you
There's a lot of
So we just have to find this.
Struggling with this one.
Along a straight line, you have acceleration. Okay, they give you their values for velocity, and then what's your value for position, and they want to know in what position it sits. So if you integrate, when you have acceleration, so if you integrate acceleration, what do you get? That's what you have to do.
Oh, okay. I have to plug that in my calculator.
You have to know that top position, velocity, and acceleration interact.
Oh, yes. It's higher velocity.
Okay, so if you integrate acceleration, so start writing stuff down on your paper.
Why is that negative 1 minus 5?
Okay, so how do I write that?
Integrate acceleration.
So this is 5.
Integrate
Oh,
This one is 5.
acceleration, which you know is.
so it's like
No.
And then
oh, 2T.
Oh, well, that's,
Yeah,
this is where, depends on how you want to change it.
Well, yeah, but.
The box is going to be 4.
Well, so actually on this one, I think that's probably integrating this by hand.
Yeah.
So now we're going this way. Take the derivative of the
It's like almost 4
T squared
plus c.
plus C. Or C. Oh.
That's just our one.
Christian, you're gonna have to start studying.
Yeah.
You're gonna do
That's
so
the first
far.
one.
It will just be.
Yeah.
All the way. So this is now what? What function is this now?
This is
Okay, so what's that for? This is b. But, you know, on b, when prime is 0, it equals 4. So if you plug in 0 for t, so now you know how big c is.
0 squared is 0. Oh, it's 4.
Okay, so now you can update your velocity function. You don't need to say plus c. Plus c is equal to write out the whole thing, velocity equals.
V equals T squared plus 4.
Okay, and now you're gonna do the same thing to go, you're gonna integrate this, you go to position, and you're gonna do the same thing that we did in the first episode. We just gotta do it one more time.
I know the solution, but I think I did it wrong, kind of reminds me.
Okay, what did you try?
So, it wants to know f of negative or the negative of that, and I basically just did backwards, right? Because that doesn't.
Well, not exactly. This was 1 to 3.
Yeah, and now it's 1 to negative 2.
Correct. So you found this area, find this area.
Yeah, which is.
It's a quarter circle.
I found the area of a full circle, not a quarter circle.
So you need to divide that by 4.
Yeah,
What is that?
that's just pi.
Yeah, it's just pi.
Means it's.
Do you understand why it's negative though?
Yes, because it's going this direction.
Correct.
So then you're gonna go this direction,
If
right?
you're going left to right, you add right to left, that would be the opposite.
Yeah.
The opposite direction.
Sorry, that plus 4 is getting, that gives us the, on the, when I'm integrating this one.
So what can you take the derivative of to get 4?
4x.
Okay, well in this case 4.
4t.
Plus c.
Plus 2.
So now you got information you can solve for c. And you have the position function, and then you need to position it at 26. Have you done? You got the two things I wanted to do cross-reference. One of them was the notes, which you should have, and then this one needs to be turned in by next class. But you might as well do it now.
It's turned in.
At first it was like, so, wait, what was 70?
Maybe it's just fine. I think it's pretty easy.
The work that you have to do for each question improves.
Yeah, but
You have to know
if
a
you
few
don't
things.
understand it, I don't know, I don't
That means it's a total of 15.
Guys, I really think that we missed
Oh, yeah, yeah.
Okay, okay.
I think I missed one because I finished it, but I didn't do all the problem. Yeah, because I'm just gonna do it.
So I think you need to put 5 and minus.
Because the only ones I did it was this way.
Right, you're not adding anything to your print, you're just taking it away. No, it is the rate how much, you're saying,
Certified, I'm gonna get two of the same.
and I'm gonna add how much ink is going away? You're creating ink as you print more stuff?
Well, hopefully I'll do these and that one will be the one.
It's going away.
What should be?
I got an answer for that, which is 40, so that would be Wikipedia.
See what I'm saying? So this is the wording there. You know how fast it's going away, how much information
So
we're
that's
bringing
not
in.
what it's done, it took from one narrative to where pages.
This one's gonna connect up to this one.
Oh, okay.
Power of elimination. Process of So velocity equals v squared. Just
I got 77.
No, because you have to add on.
Yeah, it was like 77.
I know one on
If you integrate a place. First you have to integrate the 2 here. Which is like the normal, like, same thing. You just multiply by 6 and add 5.
Wait, why is it 2T?
That's when you integrate. That's something like that.
What is the 16?
Plug it in.
So it's 4 plus the integration plus 5.
That's because like, I'll put it like in my bike holder and like I'll put it in so tight that like it'll scratch the pen.
I got 45. If I do this integration. Why is it 1.6?
It's actually 6. And the same thing. Do it again.
Or someone text me. She'll text me something and she'll text her from the group chat. It's still 16. Like, girl, you just said that. I remember going by mistake.
Velocity is the it's just something that I did one press
Sorry, I didn't give you guys much warning here, but you're down to just a minute. If you need to finish this up for homework, then you can. But the other one needs to be turned in before you guys go. So I want the notes turned in so I can get those graded. There's no reason that should not be finished. There's no school next Monday, Martin Luther King Jr. Day. So I will not see you till this time next week. Make sure you feel pretty good about this handout, even if it means you need to do it a second time. It's really important.
The only kind of missed. Okay, so if you want to go from acceleration down to velocity, you need to integrate it, but you're going to have to integrate it by hand. So you need to think about what can you take the derivative of to get 2t. It'd be just the square root, plus c, plus c. And they give you enough information that you can solve for b. Have a good day. And then you can integrate that to get position plus c. And then you can use this information to solve for its c. Then you've got the full equation, and then you can figure out the position of times 6. think I get it. I'll figure it out if I don't.
Is the quiz on